Bismillahirrahmanirrahim. Now we move to the 5.2, first order linear equation. In this subtopic, it is important for you to know about integrating factor method. Okay, so how to apply integrating factor method? So the first step, you have to make sure your linear first order differential equation is arranged in the following form. So we have dy over dx plus pxy is equal to qx. Let's say for example, we have dy over dx minus 2y is equal to 0. So now we have our px here is equal to negative 2. So the general form should be pxy. Therefore, our px is negative 2. And then our qx is the everything that you have on the right hand side. So in this case, our qx is equal to 0. So please take note that our px and qx can be a function of x or a constant. So for example, our qx in this example is a constant, and our px in this example is just a constant as well, which is negative 2. Okay, step 2, you need to find out the integrating factor or if. Normally, we denote as mu. So, how to get the IF or integrating factor? Mu is equal to E integrate of your Px with respect to x. Okay, so we try to look at to the previous example. Dy over dx minus 2y is equal to 0. So, since we already identify our P, so how to get our integrating factor mu? So, it is equal to e power of negative 2 dx. So why it is negative 2 dx? Because our p is negative 2. So this is how you get the mu or integrating factor. Therefore, when you try to integrate this part, so you will get e power of negative 2x. So it is actually plus c, but you can just ignore, then we can put it at the last step. Step 3, you have to multiply equation by the integrating factor. So this is your general form. So you multiply both sides with mu. So you will get mu dy over dx plus mu pxy is equal to mu of the qx. Okay, so the idea here is when you try to differentiate this function, you need to apply product rule. This is the term that you get after you apply product rule of mu y. When you try to differentiate mu y, of course you have to apply product rule, then you will get something like this. So in short, you just get differentiate of the mu y is equal to mu of the qx on the right hand side. Okay, so let's look at to the example. So your example just now, dy over dx minus 2y is equal to 0. You already get the integrating factor, which is e power of negative 2x. And then the step 3 shows that you have to multiply the equation by the integrating factor. So you multiply both sides with the e power of negative 2x. So you can just simplify, and then you will get e power of negative 2x of your y. So as I mentioned just now, this term you get from product rule of the e power of negative 2xy, or in general, when you try to differentiate your mu of y, you will get like this. So it is equivalent to e power of negative 2x, you times with 0, so you just get 0 on the right hand side. Okay, next step, integrate both sides with respect to x. This is the last term that you get just now. Differentiate e power of negative 2xy is equal to 0. So when you try to integrate your d over dx of the e power of negative 2x of y with respect to x, so you will get back that e power of negative 2xy. So this one you can cancel out, so that's why you just get the same term here, which is what left is your mu y. So in this case, e power of negative 2xy. And then the right hand side, you just have to integrate as usual. So in this case, since you try to integrate 0, So what left is only 0 plus c. So the last step here, you have to divide both sides by mu to find out y in terms of x. So when you try to divide both sides, on the left hand side you will just get y, and then on the right hand side c over e power of negative 2x. Then you can just rewrite as y is equal to c e power of 2x. So this one is your final answer. Now look at the example 2, page 289. Solve the differential equation. We have here dy over dx plus 3x squared y is equal to 6x squared. So what is the first step? You have to make sure everything is in order. So it's already in order. We have dy over dx plus pxy is equal to qx. So therefore, you already identify your px. So our px is equal to 3x squared, and this is your qx. So qx is equal to 6x squared. So the next step, you have to find out the integrating factor. So we let our integrating factor as mu. So mu is equal to e power of, integrate your px with respect to x. So 3x squared dx. So what you will get is e power of 3x cubed over 3, and then you simplify, so you will get e power of x power of 3. And then the next step, actually you multiply both sides by mu. So for this example, I will show you the longer method, but for the next example, you can just skip that step. Okay, so let's say you multiply both sides with the integrating factor, e power of x cubed times dy over dx plus e power of x cubed 3x squared y is equivalent to e power of x cubed times with the 6x squared. So as I mentioned just now, this is the terms that you get after you apply product rule of d over dx of the e power of x power of 3y. So when you try to differentiate this one, you will get this one. Okay, then your right hand side remain as e power of x cubed times with the 6x squared. So I just put 6 in front, so x squared. So what you have to do next is you have to integrate both sides with respect to x. So integrate this one with respect to x, integrate this one with respect to x. So this one you can cancel out. What left is only e power of x cubed y is equivalent to 6. You can just put it outside. So 6 of the e power of x cubed times with the x squared dx. So I'm not integrate yet for the right hand side. I not integrate directly. Therefore, you have to apply substitution method. So for this part, integrate e x cubed of the x squared dx. So we let our u is equal to x cubed. Differentiate u, so you will get 3x squared dx. Then 1 over 3 du is equal to x squared dx. So this one will become 1 over 3 e power of u du. Then integrate, you will get 1 over 3 e power of u. It should be plus c, but you can just put it later. So substitute your u in terms of x. So you will get 1 over 3 e power of x power of 3. Okay, so you can just put this answer here. E x power of 3 y is equal to 6 over 3 e power of x power of 3, and then plus c. Then you can simplify here, so you will get 2 e x power of 3 plus c. Then you have to put y alone, so you divide both sides by e x power of 3. Then on the left hand side you will get y. Then on the right hand side you will get 2 plus c over e x power of 3. And then you can just write your final answer. Y is equal to 2 plus c e power of negative x power of 3. So this is your final answer. Now look at to the example 3. Solve the differential equation. We have here dy over dx plus y cotangent x is equal to cosecant x. So the first step here, you have to identify your px. So our px is equivalent to cotangent x, and our qx here is equal to cosecant x. Then what we need to do is you have to find out the integrating factor. Mu is equal to e, integrate your px, integrate cotangent x of the dx is equal to e power of ln sine x. So e power of ln x, we do have the properties when you have e power of ln x, so it is actually equivalent to e power of ln sine x, so it is equivalent to sine x. So multiply both sides with the integrating factor, you will get sine x dy over dx plus sine x of the y cotangent x is equivalent to sine x. So cosecant, you can just write as 1 over sine. Therefore, here 1 over sine x. You know that this part you will get after you apply that rule or after you try to differentiate d over dx of the sine x y. So it is equivalent to this one. You can simplify, you just get 1. The next step is you have to integrate both sides with respect to x. So integrate both sides, cancel out this one. So on the left hand side, what left is only sine x y is equal to x plus c. Then we divide both sides by sine x. So on the left hand side, you will get y is equivalent to x plus c over sine x. Or sine x, you can just put as 1 over sine x. So what is the sine x? So sine x is actually, this one is actually cosecant x. Therefore, your final answer y is equivalent to x plus c cosecant x.